Greetings, friends. Mainstream education teaches that the Earth is 4.54 billion years old. That's a lot. That's very difficult to conceptualize. Not that that's proof that it's false, but it's something that we should look into. That's incredible. And the main underpinning for this is radiometric dating. This is a sophisticated scientific method done in laboratory on rocks, measuring potassium argon and argon decay rates, or the radioactive decay of the isotope. This is the main underpinning. They have a way of inferring the age of the Earth, the age of the stones, the rocks themselves. The Earth is made of rocks, although it's obviously not made of all solid rocks. It's not made all of solid rock, but they're dating this rock, which goes back all these years based on radioactive decay. They do this for carbon dating as well, but the carbon dating is only good for organic material, so it's not as, can't really give you these. It can give you big dates, but maybe not on the level of radiometric dating. Now, can we measure the past? Were we there to see what was the radioactive isotope level, or what was the level of whatever atom you're tracing? Can you measure it? No, it's all inferred. And actually, there was a guy who published I think he was an academic, I'm not sure, but he got this published academically, and it caused a stir some years ago. He took known roughly 30-year-old mineral samples, basalt, from St. Helens in the U.S., where the eruption occurred. When was that? In the 80s? Around, or 70s? I don't know. And everyone knew that the rock was recent. He took it and then he gave it to a laboratory for radiometric dating, and they gave him all these different dates, like 350,000 going up to, he gave them like 5 different or 6 different samples, and the lowest date was like 350,000 years old, and then there were others that were going up to multiple millions of years old. Now I looked on Google, and of course Google is going to give you the official criticism right away, and I'm reading the official criticism. Some other academic is hemming and hawing, and so I'm not saying that this guy is perfect. There could be legitimate problems with what he did. Some of the criticism, it wasn't that substantial, but they were saying like, oh, he chose the wrong samples, and he knowingly sent these samples to the laboratory, knowing that they wouldn't be able to give a result that would be a valid result. And then anyway, the main thing that he was saying is like, look, with this radiometric dating, that laboratory, and in general, I'm not sure, I'm not an expert on this, but they're saying we can't test beyond 2 million years. You see, after 2 million years, then it starts to become apparent in the isotope level. So you're not going to get much of an answer before 2 million years. So you see, if you haven't been paying attention to what I've been saying here, there are a lot of assumptions. There are a lot of things that we are holding on faith. And it's not necessarily a wrong thing to hold some things on faith. But you should recognize what's going on here and how this is obviously theoretical. This is not a proven law. This is all very speculative. And this is the main thing that the age of the Earth and much of the dating of things in the Earth is based on this abstract, far off, indirect form of looking at rocks in a very, specific way. I'm not saying indirect, like you can directly take the rocks, but for the average person, we don't have access to a microscope that can show you atoms. And it's a few men in a room, men and women, are doing their thing, and God bless them, they're knowledgeable. They are scientists. But don't treat them as a priestly class either. Well, you can do that, but then just be honest about it. Of course, like I said, we can't observe the past and directly measure it. We can't say if the rocks have been contaminated with other atoms. These are just some of the other, things you might, a wrench you could throw in the radiometric machine. You could say, yeah, it could be contaminated. You can't prove that. The accretion of what they call daughter atoms. It's not like what they call decay. It's like one atom becoming a daughter atom. It's not really breaking down or anything. It's just that the level of neutrons is changing, I believe, or electrons. And so this is, you can't actually prove that this formation of daughter atoms is a constant process. This is another one of the main assumptions, is that the processes we observe in nature right now act at the same pace throughout the geological record, throughout history. It's always, these forces are always occurring at the same rate. Now this might apply more to geological dating, and but I think they use this in the dating of rocks too, this sort of assumption that these, like, the decay rate has to be the same at all times. And I don't know what to believe. Honestly, on that case, I don't know what to believe one way or the other. It could be constant, could be not constant. But we don't really know. And then they say that the age of the oldest terrestrial rock gives a minimum age for the age of the Earth. And this is assuming that no rock has been intact for longer than the Earth itself. But we know that, we don't know, but based on the formation of the Earth and what they say, it came from dust, and there's asteroids hitting the Earth, and so there obviously are going to be other rocks which are older than the Earth, and they found meteors which they claim are older. So then they'd say, oh, well, it was all gas back then, there wasn't enough rock. I mean, who knows? But I'm just saying that clearly there's a lot of gray area here. There's a lot of things that aren't, quite clear. So that's pretty much, the sketchiness of radiometric dating. Carbon dating, similar, but only for carbon material. It's the decay rate they're measuring in the ratio of two kinds of isotopes of carbon. An isotope is like an atom of carbon. Carbon 12, which has 6 neutrons. This is normal carbon, it doesn't decay. And then carbon 14, which has 8 neutrons. This is a rare and unstable form of carbon. It decays. And they say the half-life is 5,730 years. So half of the sample will decay to a more stable form of nitrogen. I don't know what they mean by now. I'm just looking at different sources online in my preparation for this video. Not an expert here, just sharing my thoughts, but I don't know why they're saying nitrogen, because I thought they were talking about carbon. But anyways, they say carbon 14 is produced when radiation from objects like the sun interact with stable nitrogen molecules floating in the atmosphere, and then the C14 ends up in carbon dioxide and it works its way into plants and animals. Historically speaking, they say the ratio of C12 and C14 in the atmosphere has been relatively consistent over the years, so researchers expect a predictable ratio in plants and animals. Now, if you got lost there, so did I. I'm just a simpleton. I'm just a dumb. I can't think like them scientists. Them scientists know how this all works. But it just goes from, okay, well, the sun is pouring its radiation into these molecules in the atmosphere, which are floating around, and then that gets into carbon dioxide. Okay, we breathe it in. Okay, all right, it makes sense. It's like, all right, but again, are you in the atmosphere? Do you have nano robots floating around in the atmosphere, constantly measuring this? It's like, no, it's all inferred. It's very speculative. That's fine. It could very well be. It does happen, I'm sure. I'm not denying it. So yeah, but there's a lot of connections there. There's a lot of from this to that to that. And then, of course, I won't get into, there's theories on the formation of the solar system and inferring how old the Earth is, but let's not get into that. That's very vague. So to conclude, I've showed that carbon dating is probably better than radiometric dating, but there's plenty of scientists and academics will question these things. It's not like no academics don't. It's just you're not going to hear about it so often. You have to go looking for these things. And they do. Plenty of academics do question these things. Finally, they use superposition of rock layers, a law of to date the Earth, to date rocks, to date sediments, and I think there's a lot more truth in this. They also, I should have mentioned they use tree rings. Things like tree rings, you can see the ancient wood expanding, and generally it expands in a year, so you can kind of count the years that way. So that's more credible. Not perfect, of course. I'm not even getting into the formation of fossils. You can make fossils in much shorter times than millions of years. So I'm not saying fossil creation is perfect either, that it shows, it must have been made millions of years. No, it depends. It depends on the processes and what's going on. And when it comes to geology, looking at the natural landscape, the superposition law states that the older material is always underneath and the younger material is always above. And I guess that's going to be true a lot of the time. Is it always true? No, they say this is only the case in undisturbed soil. Okay, so there hasn't been no volcano blew up the landscape, and sediment is accumulating there over millions of years. But at the same time, these same chemists and biologists tell us that everything is constant flux, and physicists tell us that everything is in constant state of motion. In the chemical world, in the natural world, there's erosion and stuff. So it's constantly changing, but then we have to have undisturbed soil so that we can see which is, and of course then there's faults that come and move some of the soil, like an earthquake or a tectonic shift. By the way, they also measure, they say that the Earth's crust by Japan is the oldest on the planet, and then they can measure the radioactive layers in the Earth's crust in bands proceeding eastward from Japan as you move across the Pacific Ocean. And that the whole theory of tectonics itself, that there's tectonic plates going and one underneath another, and this is happening under Japan, and that's why they have the Ring of Fire, volcanoes, and all. Now, again, there may be some truth in that. Do I believe all the mechanical bands? Yeah, they can get real data there. Does that necessarily prove that the Earth is 4.5 billion years old? I don't think so. I don't think that's sufficient. It's all, a lot of it depends on what are your assumptions. But in the natural world, and again, they're assuming that, the same processes are always operating here. That it's always been like a river eroding the side of a canyon. That's always been proceeding at the same pace, year after year after year. Rivers weren't more erosive 2 million years ago, I guess. And I don't know if the Earth is 2 million years. I don't know how old the Earth is. I don't think it's as young as some of the Christians would say. It's very young. But I don't think it's as old as most of the evolutionists say, because I think, the evolutionists are doing it because that's what they're taught, but it makes their theory, it fits their theory, and I think that's the main reason that they inflated all these timescales. But the Earth could be old, could be, who knows how old it is, and it's not ultimately important to any spiritual worldview, but it fits in with certain worldviews. The Earth does fit in there, so that's why we can't get too fixated on the nature of the Earth, but you can't quite ignore it. You can't quite ignore it either. So, and the other thing with the superposition of soil and sediment, it's okay, but again, I may sound like a simpleton here, but clearly that's not happening everywhere on the planet, because the Earth is not continually gaining mass, and we're the level of the ground is not continuously rising everywhere on the planet since the Earth was formed, is it? Because we have mountains, we have canyons, we have erosive processes, and then we have deposition of that sediment. So again, I'm not providing a clear answer here. I'm just trying to look at some of the gaps here and show how this is all very. It's not covering everything. It's not very straightforward, I think. This is what they tell us about how old the Earth is. Well, the older stuff is underneath, and a lot of the time the older stuff is going to be underneath when you dig down. Yeah, sure, it makes sense, but that's good too. That's good relatively. It's good relatively, but it's not. It doesn't give you an absolute number. The absolute number, they're just they're inferring it on these sophisticated dating methods in closed laboratories that you have to rely on for their expert answers. And like they tried to take down the guy who was, and it wasn't just St. Helens. They've shown other radiometric flops where it just gives completely old answers. That wasn't the only one. But I mean, you can attack those examples, but I mean, you can keep finding those examples too. So in conclusion, we can observe some things in nature, yes, that show us that these things are relatively old, like stalagmites in caves, tree rings, to an example. But you also have to be, you have to be a little skeptical of some of these grand claims of this, of what the evolutionist narrative teaches. This grand time, you have to question a lot of these things because it is abstract, it is indirect, it does rely on a lot of things that are first principles. And so it's all theoretical, nothing wrong, because science has a theoretical level, but they seem to think that they also have all the empirical stuff taken care of and all the, the direct observation. They're entirely missing that. We don't have a time machine. No matter what science fiction people say, we don't have a time machine, so you can't go back to see what was going on, what was the chemical level in these elements, what sediments were actually going here, where rocks came from, what was actually going on at the creation of the solar system. This is beyond any of us, and this should be very humbling for us. That's pretty much it. It's a worldview made by man, and it's constantly changing its message, by the way. Science 30, 40 years ago was singing a different tune than it was at the turn of the 20th century, let alone like 300, 400 years ago, where it was almost in the realm of magic. And even now it's different. What they're talking about dark matter, they're not talking about dark matter, they're this and that. And I know dark matter is a different, it's like astronomy, but still, it's science constantly changing its tune. Even since Darwin's time, it's been retweaked again and again. Hasta luego, amigos!